So today we are going to be solving polynomial equations. It's section 5.5. So I would write this down in your notes. I did not print it out for you because technically you already have most of what we're going to be doing today. Today we're going to be reviewing factoring methods back from chapter 4, section 3. So that's why I didn't print out all this stuff. We're only going to have a couple of new things today, and that's what you're going to be jotting down in your notebooks. So right now, let's start with the title, 5.5, Solving Polynomial Equations. So what does that title mean to you? Solving polynomial equations. We're going to solve what kind of equations? And what is a polynomial equation as opposed to what we were doing before?
Form or numbers.
All right, so like let's say before we would solve regular equations, we would solve quadratic equations. Now we're going to be solving cubic equations. We're going to be solving quartic equations, something to the fourth power. We're going to be solving equations to the fifth power, to the seventh power, that have like x to the seventh in there. So we're going to be solving all these crazy looking equations. But in order to do that, we need to really go back and review and strengthen our factoring skills. So right now you could just relax and pay attention. What is factoring? We already know that factoring is like a reverse distributed property, right? These are your notes from 4.3. If you wanted to, you could go back to section 4.3 and read these notes. The first type of factoring you should always try is what?
GCF.
Pulling out the GCF. So you look at what's in common and you pull that out and you write what's left over in the parentheses. Does anybody need to see that example? Or are we good with pulling out the GCF?
Okay.
We're good, right? And then there's other methods that we learned. We learned factoring by grouping. Let's review that one. Whenever you have four terms, like right here, we have four terms, and you try to pull out a GCF, right? Is there x's in every single term? No. Is there multiples of something in every single term? No. So there's nothing to do by pulling out a GCF. So we move on to trying this new method called factoring method. What is factoring by grouping method? What is by grouping? You make two groups. You take your first two and you separate it from your second two. So you have a group here and a group there. And then what do you do from there? You pull out the GCF from your first group, which is x squared, and you write down what's left over. And right here, there's nothing to pull out, so you pull out a 1 and you rewrite what's left over. And then you take a step back and you check and see if there's a binomial in common. And if there is a binomial in common, you take that x plus 1 binomial that's in common and you pull it out of the whole thing, put it out in the front, which means that these guys are left over and come down. So your final factored form answer is this. Again, this is something you already learned, you were already tested on. I hope we remember factoring by grouping. Yay? We are going to need this stuff, all these factoring skills on today's lesson, or on today's actual lesson section. All right, we also learned how to factor standard form quadratic trinomials. Remember, a standard form quadratic trinomial is simply ax squared plus bx plus c. And we know that it's really easy to factor this guy when that leading coefficient's 1. If the leading coefficient is 1, all you do is set up this situation right here, the parenthesis, xx, and you think what times what is the last number that if you combine together is the middle number, and you plug in those numbers right here. You guys remember that? Okay, good. So here are some examples in case you forgot. So right here, the a value is 1, a value is 1. So all these are a value of 1. So you can think what times what is 6, that if you add together is 5. Oh, that's 3 times 2, right? That'll give me 6, and if I add it together, it's 5. So you put a 3 right there, 2 right there, and your x's are right there. It's that easy. Okay. What times what is negative 6, that if you combine together is negative 5? Oh, that's a negative 6 times a positive 1, right? Negative 6 times positive 1, that'll give you a negative 6. And if you add negative 6 and positive 1, it'll give you a negative 5. So negative 6 and positive 1 go right in there where your x's are out here in the front. Very simple. I hope we remember that. There's also another method, factoring completely. What does that mean? Well, start with the first type of factoring that we learned, pulling out the GCF. So if we look at this guy right here, there's 3 terms. There's something in common in all 3 terms. Let's pull out that GCF of 2x. And whatever's left over, you write inside. But then you realize, hey, this is a quadratic trinomial that could be, or maybe could be, factored further by doing this. And you simply think, what times what is negative 20? That if you combine together is positive 1. And you could make a list if you want to help you out, but you should conclude that it's a positive 5 and a negative 4. That's why there's a plus 5 right there and a minus 4. And that GCF you pulled out, you just put it in front. That's called factoring completely. So you factor, and then you look at the inside of the parentheses and see if you could continue to factor with a different method. And then we had the most fun part of Chapter 4, which was factoring a quadratic trinomial when your a value is not 1. Right? And we had that long process. Step 1 was to multiply a times c. You get an answer. And then you make a list. You think of the multiples of that answer that combine to give you the b value, whatever number's here. And then step 3 is you use that pair of numbers from step 2 to rewrite this guy as 2 terms. That way you could get 4 terms instead of 3 terms. That way you could factor by grouping. A lot of us hated that long method. A lot of us never were able to get that long method. But after that, I showed you a shortcut on that. That magical shortcut where you magically divide each binomial. So it's up to you if you want to use factoring by grouping, or you could set this up. Let me guide you through it. Step 1 is to multiply a times c, right? So let's look at this first practice problem. Everybody go ahead and jot this down in your notebook. Let's actually practice this guy. And it should say factor. Let's factor 6x squared minus 7x minus 3. So step 1 is to multiply a times c. Everybody do that, please. So what is a times c? Negative 18. That is your answer for step 1. Step 2, think of the multiples of that answer that combine to give you the b value, which happens to be negative 7. It says tip, make a list. All right, so step 2, let's make a list. What times what is negative 18? Negative 1 times 18. Let me write that better. Negative 1 times 18. Negative 2 times 9. Negative 3 times 6. Negative 4 doesn't work. That's it. That's all the possible ways of getting negative 18. Now, which pair of numbers combines together to give us this middle value, negative 7? Okay, yeah. Negative 2 and 9, when you combine them, it gives you a positive 7. So that's absolutely the right number, but just the wrong sign, which means we have the right numbers, just the wrong signs. So change that negative 2 to a positive 2, change that positive 9 to a negative 9, and that's the correct pair of numbers that we want for step 2. Now, the old method was to rewrite your trinomial as a polynomial by replacing this middle value, negative 7x, with these two numbers. So you could write 6x squared plus 2x minus 9x, and then take away 3. That way you could have 4 terms. That way you could factor by grouping, but that in itself is another 3 or 4 steps. So here's the alternative, quicker method. Make your factored form format ax, ax. So what is your a value? 6. So I'm going to put 6x and 6x. Everybody do that. Now what belongs in this blank spot? The pair of numbers from step 2, right? Negative 9 and positive 2. So let's take that plus 2 and minus 9 and put it right in there. Plus 2, minus 9. And here is step 4, the magical step of reducing or dividing, think GCF of each binomial, if possible. If you can't reduce it or divide it, then just leave it. But right here, 6 and 2, what could you divide both of those by?
2.
By 2. So what's my answer going to be if I divide both of them by 2? 3x plus 1. And over here, 6x and minus 9. What could I divide both of those by?
3.
By 3. So what do I get? And ladies and gentlemen, we have factored. This is it. This is the answer. So it's up to you if you wanted to use factoring by grouping. I prefer this method. It's quicker, it's faster, it's nicer. And you will need to know all of these different factoring methods when we start doing the actual section of 5.5. Now, in the past, we've already factored perfect square binomials, all right? But I never actually gave you the difference of two squares formula, all right? So go ahead and jot this down right now. Write down difference of two squares, and then write down, remember, difference is minus, so put a squared minus b squared equals, and then put binomial times binomial, a plus b, a minus b. Go ahead and copy that difference of two squares formula. And the reason why I didn't really emphasize the difference of two squares formula is because you don't really need it. Like on number 1, you could think what times what is negative 9, that if I combine together is a middle value b, which means that there is no middle value b, which means what times what is negative 9 combines together to give you nothing. So what would number 1 be if I were to factor it that way? What times what is negative 9 that if you combine together is nothing? Positive 3 times a negative 3. That'll give you a negative 9, and if you combine them together, it's nothing, right? Do you guys remember that? Another way that we looked at this was, perfect square term here, perfect square term there. Square root it, you get x. Square root it, you get 3. So you're going to be using x, and 3, and one has to be a plus, and one has to be a minus. You guys remember that? Okay, so it doesn't really matter which way you look at it. You should be able to factor it with whatever way you want. Now, this next one, yeah, I could think of, I'm going to square root. Yeah? So what's my answer going to be if I square root both terms and plug it into our answer format? 5x with a 6, 5x with a 6. One has to be plus, one has to be minus, right? But how about this? I want to show you how to use this guy. All right? So let me go back and erase the answer. And let's use the formula. The formula says if you have something squared minus something squared. Now, do I have something squared here? Yeah, technically I do. But over here, do I have something squared? No. So what I want to do is I want to start practicing manipulating terms so they could look like what we want them to look like. So in other words, I want this to look like this. I want something squared minus something squared. So I'm going to rewrite this as something squared minus something squared. Now, what value could I put in here that when I square it will actually take me back to the 25x squared? 5x. And what value could I plug in here that when I squared it takes me back to 36? 6. So why would I do this? Because now I could kind of identify what my a value is and what my b value is, right? And I could use this formula and put a plus b, a minus b. A plus b, and then a minus b. Probably should have done that in red. Does that make sense? How I applied the formula? Okay, now you don't have to, right? Because you could have just said, I'm just going to square root it, get the 5, square root it, get the 6, one's plus, one's minus, I'm good. But look at number 3. That's not even a quadratic anymore. That is a 6th degree binomial. So if I told you factor this, then you'd be like, okay, let me see. Could I pull out a GCF? No. Well, this is not even a quadratic. I don't know what to do. And you're actually stuck. You don't know what to do. But if you apply this difference of two squares formula and make it look like something squared minus something squared, you will be able to factor it. That's if you could write it that way. So let's start by trying to write it that way. Let's do something squared. Let me actually make it a little bigger. Something squared minus something squared. Let's see if we could rewrite it this way. So think about something in here that if I multiply it with itself, it'll give me 49x to the 6th. What do you guys say? 7 x cubed, or 7x to the 3rd? Definitely, right? Because the rule of exponents says you could distribute the 2 to the 7, that'll give you 49, the 2 to the 3, power to a power, you multiply to take you back to the 6. So how about over here, what will be in here? 3, why? So check it out, guys. We did not know how to do this, but now this kind of looks like a difference of two squares, right? And now we could use this formula that says, parenthesis, one has to be plus, one has to be minus. And what was the a value? The whole purpose of doing this was to identify the a and the b. So just put those right there, put those right there. Put those right there, put those right there, and we're done. So we have 7x to the 3rd and 3y, 7x to the 3rd and 3y. So we were able to factor it. This is the factored form of the original 49x to the 6th minus 9y squared. Bless you. If you were to distribute and combine like terms, you would end up with the same original 6th degree binomial. Pretty cool, huh? All right. Now it's time for the new stuff. Everybody please copy this new stuff down. I want you to copy this right here. The factoring with sum and difference of 2 cubes formula. The bad news is we're going to have to memorize these 2 formulas. We're going to have to memorize them. The good news is that I have a couple of tips on how to make it easy to memorize them. All right? So copy it down. Copy down those practice problems. I'm going to pause it, and then we'll go over it together right now in class. So this formula, the sum or difference of 2 cubes, it's easy to remember. Why is that? Well, sum, what does sum mean? Addition. 2 cubes, you know what 2 cubed terms are. So if you have something cubed plus something cubed, then your formula will be a binomial times a trinomial. So remember that. It's going to be a binomial times a trinomial. Okay? Now, this first binomial will be exactly this without the cubes. Just a plus b right in there. Same thing down here. Look, it's a cubed minus b cubed on the difference of 2 cubes. The first binomial is simply going to be a minus b without the cubes. So again, sum or difference of 2 cubes, you're going to have a binomial times a trinomial, and that first binomial is going to be the same exact thing without the cubes. So you're not really memorizing anything right there. And over here, it always starts out with a, because a is the first in the alphabet, a before b, a squared. And if you had a plus sign here, then this one's going to be a minus. If you have a minus sign out here, then this one's going to be a plus. Okay? A squared minus ab plus b squared. Simple as that. A binomial times a trinomial. This first binomial will always be the exact same thing, but without the cubes. First binomial is going to be the same exact thing without the cubes. And whatever sign you have here, which you had originally, it's going to be the opposite in the middle. Will a squared always be positive? Yes. Will b squared always be positive? Yes. How could you remember that? Well, if you square anything, it'll end up being positive, right? So that's another way of helping you remember that a squared is always positive on both. B squared is always positive on both. All right, so now it's time to show you how it actually works. Let's look at number 1. What am I going to use? The sum of 2 cubes or the difference of 2 cubes? Difference. Now, in order to identify my a value and my b value, I need to rewrite it as something cubed minus something cubed. So I have the something cubed here, but I don't have a something cubed here. So let's all start out by doing this. This is very important. And this is actually not part of the formula. This is only to identify the values that you're going to be plugging into the formula. So obviously, what would belong in here if you want it to be an x cubed? X. Yeah, just x. And what would be in here if you want this to be an 8 at the end of it all? 2. So that's a very important part because that's how you identify that your a value is really x and your b value is really 2. So here's the formula. Here comes the formula. Binomial times a trinomial. I put parentheses and I put some bigger parentheses. Okay? Now, what is this first binomial? It's the same thing without the cubes. So what's going to be in here? X minus 2. Okay, that's the easy part. Now the fun part is we know we're doing the difference of 2 cubes. So this is really a squared. If this was a minus, it's going to be a plus ab and then plus b squared. Now, I want you to, like the quadratic formula, as you say it, write it with parentheses, all right? So we're going to go a squared plus ab plus b squared. I know it's weird that we're writing parentheses inside parentheses, but it's really the best way to do this. If not, you're probably going to make mistakes. So what is my a value?
X.
And my b value?
-2.
Just 2. Okay, so my a value is x, so I put an x right there. A value is x, put an x right there. B value is 2, put a 2 right there. B value is 2, put a 2 right there. And now we simplify that trinomial. So on the inside, we're going to have x squared plus what? 2x plus what? 4. And out here, the binomial in the front, you just rewrite it. And ladies and gentlemen, we are done. We have factored using the difference of two cubes formula. Now, yes, of course, you're supposed to look at the inside of the parentheses and see if you could continue factoring. Some of us are going to think, oh, 4 times what is 4 that if I add together is 2? You can't do it, so that's as far as you could go. That's completely factored right there. Now, that first one was pretty basic. This next one's a little more interesting. Is this going to be a sum or difference of two cubes? Sum. But then again, this one's a cube term, but this one's not a cube term. This is a sixth power, right? So we need this to be something cubed plus something cubed. Now, maybe we could change it, maybe we can't. But let's do it. Let's try it at least. So this is the first most important part, to identify what your a and b value are. This is not part of your formula. It's just identifying what your a and b value are. So what would belong in this first parenthesis in order to end up with 8c cubed?
2c.
2c. And what would we need over here, this is a little bit more challenging, to end up, when you cube it, to end up with 27d to the 6th? 3d squared. Perfect. Because 3 times 3 times 3 is 27, and d squared times d squared times d squared, or power to a power, you multiply them, you get d to the 6th. So that's a very important part, because that's how you identify what your a value is. Your a is 2c, and your b value is 3d squared. So now let's write our formula for the sum of two cubes. We know that both of these formulas are a binomial times a trinomial. And the first binomial is really simple. What's that first binomial going to be? Without the cubes, right? So what am I going to put on that first binomial?
2c plus 3 squared.
2c plus 3d squared. And again, for the trinomial, let's just go to the formula and write this trinomial, but with parentheses instead of the letters, and then we'll plug in the a value of 2c and then the b value of 3d squared. So let's write this with parentheses. It's going to be an a squared. I would write the parentheses a little bit big because we're plugging in a monomial with variables. And then minus ab, and then plus b squared. Okay, so what is my a value? That goes right here in the first one, 2c. My a value again, 2c. My b value is 3d squared, and my b value is 3d squared. Now all we have to do is simplify that trinomial. So that trinomial, 2c squared, what's 2c times 2c? 4c squared. And now this middle part, well, you have a negative 2 times 3. What's negative 2 times 3? Negative 6. And then what's c times d squared? cd squared. You just put them together. And last but not least, if I take 3d squared and multiply it with itself, what do I get? Plus 9d to the 4th. And that is all in parentheses. That is a trinomial. Don't forget about your binomial that is out in the front, 2c plus 3d squared. Fun stuff, right? Could you believe it? This is free. You're not paying me any money. You're just having this entertainment for free. Okay, that wasn't funny. It's a long video already. What we did here, what did we do? We reviewed all of our factoring skills, and we learned a couple of new tricks. The difference of two cubes formula, the sum or difference of two cubes formula, and also the difference of two squares. But anyways, for homework tonight, I want you to just watch the video over again so it'll stay fresh in your mind when you come in tomorrow. And we're going to pick it up right here where we left off.